Hello students, today we'll study about how to resolve a force into components. So first of all, let us see what do you mean by components. Now, suppose on an object a force is acting neither in horizontal nor in vertical direction but by making some angle with the horizontal direction. In that case, the force will have two components, one in the horizontal direction, one in the vertical direction. Now, how to resolve in the components? I will make it clear by giving you this example. So, I'm drawing a right angle triangle here. Now, in this right angle triangle, the hypotenuse, suppose it represents the force F, and the angle with the horizontal direction here. One side of the triangle is horizontal. The angle, this line of F, that is the hypotenuse, is making with the horizontal direction is theta. Now, I will take this opposite side to theta as A, adjacent side as B. Now, using SOHCAHTOA, I will get cos theta. Cos is the adjacent upon hypotenuse, that is B upon F. For theta, the adjacent side is B, hypotenuse is F. So that means I can write B is equal to F cos theta. So the adjacent side of theta, I can write it as F cos theta. Similarly, sin theta is opposite side upon hypotenuse. That means opposite side A, I can write it as F sin theta. So, this shows that along the adjacent side of the angle theta, there is a cos component, and perpendicular to the cos component, there will be a sin component. Many times students by heart the component as horizontal cos, vertical sin. That is wrong. Keep it in mind that along the adjacent side of the angle, there is a cos component, and perpendicular to the cos component in the same quadrant, there will be a sin component. So to make this concept more clear, let us take some problems here. Now, suppose a force here acting on the particle is situated at the origin, and the force acting is of 10 Newton, and it is making an angle of 25 degrees with the horizontal. Now 10 Newton force will have two components. Now since 10 Newton force is in the first quadrant, the cos component will be in the positive x direction, and that will be 10 cos 25, because x direction is the adjacent side of 25 degrees. The cos component will be along the positive x direction, and that is 9.06 Newton. Similarly, the sin component will be perpendicular to the cos component. So the sin component will go in the positive y direction. So Sine component will be 10 sine 25, and that will be equal to 4.22 Newton. So, since the vector, that is the force, is in the first quadrant, the cos component will be along the positive x direction, because x direction is the adjacent side of the angle of 25 degrees, and the sine component will be along the positive y direction. Let us take one more problem here. So here the force of 15 Newton, again it is acting in the first quadrant, but now it is making an angle of 32 degrees with the y direction, that is with the vertical. So keep it in mind that in this case the positive y direction is the adjacent side, and hence along the positive y direction now there will be a cos component. So 15 cos 32 along the positive y direction, so that will be 12.7 Newton. So this 15 Newton force will have a component of 12.7 Newton along the positive y direction, and perpendicular to that, that means along the positive x direction, there will be a sine component, 15 sine 32, and that is equal to 7.9 Newton. So this problem I have purposely given to you to make it clear that it is not always necessary that horizontal component is cos. Along the adjacent side of the angle, there will be always a cos component, and in the same quadrant perpendicular to the cos component, there will be a sine component. Take one more problem here. Now in this case, a force is acting along the x direction, and it is say 8 Newton force. Now since the force is acting along the x direction, that is in the horizontal direction, along the y direction there won't be any component. That means the vertical component of this force will be 0 Newton. So keep this in mind. If the force is acting horizontally, it will not have any component in the vertical direction. Now similarly, suppose the force is acting along the y direction. Take for example a force of 8 Newton is acting along the y direction, positive y direction, then in x direction the component will be 0 Newton. So these are the basic concepts. Let us see some problems here. So example, resolve the given force in components and hence express the force F in Pi plus Qj Newton form. So obviously here P will be nothing but the x component and Q will be the y component. So let us take the first problem here. So a force of 30 Newton is acting in the first quadrant and it is making an angle of 25 degrees with the positive x direction. Now since x direction is the adjacent side of 25 degrees, that means the cos component of 30 Newton will come in the x direction, positive x direction. That means this will be 30 cos 25. So the x component will be 30 cos 25, which is 27.1 Newton. And in the same quadrant, perpendicular to the cos, that means in positive y direction, there will be a sine component. And that is equal to 12.7 Newton. So I can write F. Now see here, both x and y component are positive. So I will write F as 27.1 I plus 12.7 J Newton. Since you know that I is the unit vector in x direction, so whatever is the x component multiplied by I plus whatever is the y component multiplied by j. That is how you can express in Pi plus Qj form. Let us take one more problem here. Now this force is of 25 Newton and it is acting in the fourth quadrant and the angle made with the y direction is 42 degrees. So the cos component will be along the negative y direction because negative y direction is the adjacent side of 42 degrees. So this will be 25 cos 42, but this will have a negative sign because it is along the negative y direction. So it will be negative 18.6 Newton. And the sine component will go in the positive x direction perpendicular to y direction in the same quadrant. So that will be 25 sine 42, which is 16.7 Newton, and it will be positive. So now in this case I will write the force as x component 16.7 I plus y component, that is negative 18.6 J Newton. So whatever is the x component with the proper sign into I plus y component with the proper sign into J, and that is how we'll express the force in Pi plus Qj form. So I will give you for practice. Resolve the force in components and express the force F in Pi plus Qj Newton form in each of the cases. So first case, so this is a 18 Newton force and it is making an angle of 32 degrees with the x direction. So now this force is in second quadrant, so the x component will be negative, y component will be positive. So accordingly write it in Pi plus Qj form. Then the second one, now this is a 25 Newton force and this is 48 degrees with the negative y direction. Now since the force is in the third quadrant, both x and y components will be negative. So just try these problems for homework. Any doubts, please ask me in the next class. See you students. Enjoy the day ahead. Bye.